viewers, welcome back to another section of my YouTube channel tutorial. In this video, I'm going to take you through the proof of irrational numbers. We have an example here, prove that the square root of 2 is an irrational number. First of all, let's see what an irrational number is. In the real number system, we have two main components. We have the rational aspects, then we have the irrational aspects. The rational aspects state that a number can be represented in the form a over b, where b is not equal to 0. But this expression should be in the simplest form. Take note, a over b should be in the simplest form so that you cannot divide anything further. Irrational number on the other side is the opposite, is a number that cannot be represented in the form a over b at all. The core of this video is for us to show that a number is indeed irrational. That is, a number or certain numbers cannot be represented in the form a over b. As a topic, I gave an example, prove that square root of 2 is an irrational number. Let's solve this and see. So to prove that square root of 2 is an irrational number, so square root of 2 is an irrational number. How do we prove this? First of all, we make an assumption that square root of 2 is a rational number. And from the proof, we will see that square root of 2 is not and cannot satisfy the condition of the rational numbers. So if square root of 2 is assumed to be a rational number, we will make square root of 2 to be equal to a over b. Once you have a over b, we are to find the properties of a and b and c. So let's square both sides. Square root of 2 all squared is equal to a on b all squared. And this will give us 2 is equal to a squared on b squared, right? At this point, I can make a squared a subject to get 2b squared. If you have a squared is equal to 2b squared, then we can say that a is an even number. Alright, so assuming that b is 1, you get a to be what? 2, right? So let's see. So you have a squared is equal to 2b squared. So if we just want to show that a is going to be an even number, so let's take the squares and see. Or if I make, let's say, b to be 2, this will be what? 2 to the power 2, that is going to be 4. So 4 times 2 will be what? 8. But considering the in squares form, so you can see that if you have a squared and you have b squared, the number 2 here represents what? The even nature of what? A squared, right? So without using numbers as an example, let's use this concept. If you have a number which is equal to twice a certain number, then you say that that number is an even number, because you can divide that number into 2 to get what? This, right? That is it. So you can see that if I divide a squared on 2, I'll get b squared, meaning that a is an even number. So once I've determined that a is an even number, I can make a to be equal to any random even number. How do I get a random even number? So if I take a random even number like a constant, you see, even number is twice a constant. So let's say 2c. So now I've chosen a value for a. Once I have a, I come back to my formula. Square root of 2 is equal to a over b, but here is going to be 2c over b. Then I can square both sides to get square root of 2 all squared, 2c on b all squared. And now square root on 2 all squared will give me 2 is equal to 4c squared on b squared. And at this point, I can make b squared a subject. So b squared will be equal to 4c squared on 2. And hence b squared is equal to twice c squared. At this point, we can also say that b is an even number because b is twice a number. So even number. So right now, square root of 2 is equal to a over b. We found out that a is even over b, which is also even. And if you have an even number over an even number, it's expected that the common factor 2 should cancel out. But since a over b remains this without any cancellation, such that both a and b are all even numbers, then it means that a and b doesn't satisfy the rational condition, because under rational condition a and b should be in the simplest form and there shouldn't be any constant to cancel out or any factor. For that reason, square root of 2 cannot be expressed in the form a over b with a simple nature or in the simplest form. And this shows that square root of 2 is not a rational number. Thank you for joining me in this video. Kindly like, you subscribe, and you share.